So here in this is the second part of the chapter 5, system of linear inequalities in two variables. And here we will have two linear equations and we will plot them on a same coordinate system. In that case we will see the intersectional part, that would be the solution region. So let's see how it works. For example, you are given here a system of linear inequalities. We wish to solve such system graphically, that is to find the graph of all ordered pairs of real number that simultaneously satisfy all the inequalities in a system. So there are infinite many ordered pair means xy, which can satisfy both equations simultaneously. So we cannot list all of them. So the best way is to just locate that region which contain all those ordered pair, and we call it a feasible region or a solution region. So here we can see we proceed as follows. Graph each inequality on the same axis, like here this one we will write it in an equation form, minus 1 by 2x plus 2. So we will say that if x is 0 we get y equals to 2, and if we say y equals to 0, and in that case x would be 4, I think. Yeah, so we plot this equation. Similarly, we take the second equation, x minus 4 equals to y. If x is 0, y is minus 4, and if y is 0, x is 4. So we will plot both equations on the same coordinate axis, and we will see their intersection part, like this graph, and it is this blue color, and this graph that is yellow color, and this is the intersectional part. This one is the intersectional part, so we can say that the solution region is this one for these two equations. So here you can see this is the solution region, and these points are called corner points. Why do we call them corner points? Because these points lies on the intersection of two lines, and this is an important thing which we will use it later on, the definition of corner point. Then there is another definition which is bounded and unbounded. For example, if you draw a line like this, then you draw another line like this, then we draw another line like this. So if we have three equations, this is the first equation, this is second, and this is third one, and the common portion between all these lines, this is the common portion, this is the common portion, and it is enclosed from all three sides. This is called bounded solution region. And if it is like this, for example, one line is going through this, another line is going through this, and let's say this is their intersectional part. Now here it is unbounded, we don't have any limit in this direction, we don't have any limit, so this all portion is belonging to the feasible region of these two lines, so it is unbounded. Now we solve this system of linear inequalities. First of all, we draw x greater than 0. For x greater than 0, this is the portion which is for x greater than 0. For x greater than 0. Then we plot this second part, y greater than 0. So this part is for y greater than 0. So in this way, so far the common portion is this one. This one is the common portion. so forth. Then we plot x less than 15. X less than 15 is somewhere here. So this line is x less than 15. So we left with this portion. This is the common portion so far. Then we plot this equation. It goes through this line, so it is like this, and then we plot this last equation, which one is like this. So the ultimate common portion left with this one here, you can see neat and clean. This is the ultimate common portion. So the corner points, first of all we locate the corner point which lies on the intersection of feasible region or bounded region. x00 is corner point. This one is corner point because it is touching feasible region. This is corner point. This is corner point. This is corner point. This point is not a corner point, although it is intersection of two lines. This point is not corner point, although it is intersection of two lines, but it is not lying on this feasible region. Those points are corner points which lies on the feasible region. So we have 5 corner points: 1, 2, 3, 4 and 5. Here the application, we have same problem. Suppose a manufacturer makes two types of skis, a trick ski and a solemn ski. Suppose each trick ski requires 8 hours of design and 4 hours of finishing. Each solemn ski requires 8 hours of design and 12 hours of finishing. Furthermore, the total number of hours allocated for design work is 160 and the total available hours for finishing work is 180 hours. Finally, the number of trick ski produced must be less than or equals to 15. So how many trick ski and how many solemn ski can be made under these conditions? It is the same example which we had just solved. When you model this problem, you will get these 5 equations, and as we did previously, these are natural constants like x is greater than 0, y is greater than 0. When we solve real life problem, these two constants are always there. We take them as it is, and when you plot them, as I said, this is the same example. So these are the corner points. 0 0, here we didn't mention 0 0, but it is also a corner point. Then x0, y15, this is second corner point. Then x 7.5 and y is 12.5. Then third corner point, x is 15, y is 5, and then x 15 and y 0. So here you cannot say 7.5 and 12. Normally we write 7.5 equals to 8. We write that round figure 8, round figure 13. But in case of linear inequalities, we will round it down 7 and 12, not round up, because if we round it up, it will go outside the feasible region. We have to keep it within the feasible region.